Hello and welcome to a new video about deep reinforcement learning. In the last video we have created an agent who could solve the game which we have set up in the last videos before and who is today serving as a benchmark. Our player was able to solve two difficulties himself, hard and medium, and developed its own strategies during this process. One strategy ended up in falling off from the platform because he just hunted the target very fastly and didn't care about falling or not. But the agent failed in the easiest level. Today we try to outperform this benchmark and we want to find a way that the agent is not falling from the platform anymore. So let's go. In case you have not watched the previous video, you should do this now before continuing with this one. So our first goal for today will be to implement something that makes the player not fall from the platform anymore. We introduce a quantity which we can measure. We will call it a fall percentage, so measurement of how often did the player fall from the platform. And based on this measurement, we can improve the player's behavior so that the player will not fall from the platform anymore. And with this, we will start now. To make this measurement, we want to add something to our Tensorboard. So we want to add how often does the player fall down. To do this, we have to go to our scripts in the assets and open the myAgent script. So now in our myAgent class, we want to do two things. The first thing is that every time when the agent is falling from the platform, we want to increase a counter, a fall count, by 1. On the other hand, we also want to count how often did the agent play the game. So on every episode begin, we want to increase a counter for the episodes. So the game count should be increased by 1. Both of these variables have to be initialized and they are both integer values starting at 0. This goes easy and you know this already. And now at the end of every episode, we want to log our statistics into the Tensorboard. And how you do this, I will show you now. For this, we create a new function, which we will call log statistics. And in this function, we want to use the variables which we just defined and save them in the Tensorboard. So every time when the game count is above 0, that means every time when the agent is playing, then we want to define a fall percentage. This is basically the fall count divided by the game count and given as a percentage, so multiplied by 100. And this we want to log in the environment of the Tensorboard. So to do this, we have to connect to Academy, which is basically our Tensorboard, instance stats recorder, and then we can add our measurement in the environment part. And the measurement which we want to log is not the game count, but it's the fall percentage. So also the variable fall percentage has to be saved. And that's it. That's how we can log something in the Tensorboard. And now every time when an episode ends, we have to call this function to log the statistics. And this function has to be called in all the scenarios when the game ends. Now we can just start a new training. How to do this, you know, you have to activate the environment. Then you have to use machine learning agents -learn. And then you just have to define a run ID. I will call it now fast test. but you can also skip this if you understand how it works. But here I want to just show it. So let's start a new game, press the play button, wait until the Tensorboard opens, or wait until the game begins, and then open the Tensorboard. And when we do this and update the Tensorboard, then we'll see in the environment file is now the fall percentage as a new graph. And it logs us basically the percentage how often the player falls with respect to the amount of games the player played. So now we saw that a small test worked. The fall percentage was something around 60%, which makes sense in the beginning of a new training. But now I want to delete this folder because it was just a fast test. And for the follow-up runs, I will just shortly change something in the configuration file to make measurements in the Tensorboard more frequently. This does not influence the training, but it helps me to show you a bit nicer graphs. So the summary frequency will be changed to a lower value. So now we will start with the first strategy, the most important one. It's reading up the documentation. So we will take a look in the documentation of Unity and of this environment to find the best recommended parameters for a proper training. Reading the documentation is the key to success. So for this, we're going to the Unity Technologies ML Agents, PPO, that's our policy that we are using, and to the configuration. And then we can read up the hyperparameters for our configuration file for our PPO trainer type. So to get a better understanding of this, we can open our configuration files, which we use so far. And there you can see, first of all, the trainer type PPO, but you also see batch size, buffer size, and many more hyperparameters. And now we want to take a look at these hyperparameters, what they mean and how they should be set. So now we can take a look at the batch size, for example, and in a continuous action space, which we have for the PPO trainer type, it's recommended to have 500 to 5000 batch size, and we just had 10. So this is the first value we have to increase to get a proper training. Another value then is the buffer size, which is strongly connected to the batch size, and it should be a multiple of it. So 10-fold or 5-fold of it. So in our case, we just make 10-fold. Now I want to shortly try to visualize what the buffer and the batch size are. These are two very important things or concepts in AI and deep reinforcement learning. That's why I want to show you now how you can understand them. When the agent plays, it plays different episodes and collects different experiences, different situations, and all of these situations are saved in a buffer. This will be the replay buffer of our experiences or the agent's experiences. This buffer can be made very, very large, and we want to collect there a lot of experiences with a lot of variation inside, and which gets a lot of impressions for the agent. Now we could theoretically take all these experiences and put it into our batch, and the batch is then used for training the brain of the agent. In practice, we do not use all the episodes for training because it would be very huge batch size and a very slow training. Instead, we are randomly picking different experiences from the buffer and put them into the batch. So in best case in the batch are a lot of different situations saved, but not all situations. And this small batch with still a lot of variation in the experiences will be used for the training. And then the training is fast and has a lot of different experiences. After the training, we want to play further and create new episodes, create new experiences. But to save this experience in the buffer, we have to remove old experiences from the buffer. So to get new insights, we have to remove some older experiences. This can also be problematic, but we skip this for today. And then we follow the normal procedure. We randomly take experiences from the buffer, put them to the batch, run the training, and then put them back to the buffer and collect more episodes, replacing old episodes, and continue the process again and again. And by the way, if you want to see more of these videos, subscribe to the channel and hit the like button. So now we can change these configurations in a new configuration file to basically keep track of our things that we modified. And there we can also set the summary frequency a bit higher, that we don't have so many summaries. And we can also set the maximum step size to 1 million. That should be enough for now. And now you could set the velocity scale to the same value as in the previous video, or in this case here, because I want to speed up the video a bit, I set it to 0 to directly train on the problematic state from the last video. So let's make a new run where we put the configuration directory to our new configuration file and start the training. And when the training starts, we can also directly open the Tensorboard, where we just have to type in Tensorboard and the path to our log directory, which is in our results folder. And then the Tensorboard opens and we can directly see the progress of the training. And if you let it run for a long time, we then can also see the development of the new introduced fall percentage, as well as the development of the cumulative reward, which we want to compare with the benchmark. So now what we expect with our new configurations and also with the setup that we are in the easiest environment is that the cumulative reward will increase and outperform the benchmark and comes up to a theoretical maximum value of 2, because it should always be able to reach the ball, and the fall percentage should go towards 0, so the agent should never fall from the platform. So after a while of training, we see that the cumulative reward is increasing and reaches very high values. And we also see that the agent is nearly never falling from the platform anymore. This we also see in the Tensorboard in the fall percentage, that it goes towards 0. But 20% seems to be quite high. And it's not what we see visually. So here we should take a closer look in the code again. So in case you have an idea why this happens, pause the video and write it down in the comments. And if you have no idea, it's also not a problem. We will cover this topic now, so just continue the video. To make it a bit easier for you to understand the problem, I want to go back to the configuration file and continue the training for a couple of more steps. So I want to increase the maximum step size for at least one more summary frequency. By doing this, you also directly learn how to resume a training by using this command. And with this command, you resume the same training with another configuration file, which is actually very cool to know. And if you take a look now, you see a big jump in the fall percentage. So the fall percentage is actually quite low. And maybe you realize now where this comes from. So in the code, we count all the games and we count all the falling down events, and then we basically sum up over them and build the fall percentage from all the values. So this will be a very smooth function which is hard to update. If you imagine, we make 1 million training units and then we want to build an update. This update has then only the influence of 1 out of a million, and that's nothing. So let's go back to the code and change this. And what I want to do is I want to reset our counter interval so that we every 10,000 steps reset this to 0. So we set the game count to 0 and we set the falling counter to 0. So then we have a bit less smooth but more up-to-date measurements of our fall percentage. So how to do it is on the episode begin, I just asked the question if the game count is a multiple of this reset interval, and if this is true, then set the other ones to 0. And then when we have this code running, we update every 10,000 steps the fall percentage in a hard way and not in this smooth kind of approach. We also could do this every step, but every 10,000 is a bit more smooth. So now you have learned how to use the Tensorboard to write your own measurements into it. You also have learned where to look up for the configuration file, and you have hopefully also learned what a buffer and a batch size is. And this knowledge we want to now use to train the agent to not fall from the platform anymore. So to be more careful while hunting the big target. To not make this video too long today, I would describe this in the video next week. But as a small homework, you can already think about which kind of incentives you want to give the agent, which kind of rewards and so on. And I'm looking forward to see you in the next video. Thank you for watching. And if you want to support me on this journey, please consider to like and subscribe. And if you want to support me a bit more, you can do this on these platforms. Thanks a lot and see you next time.